Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellyn, Illinois. And this video today is going to look at advanced functions, setting up functions the final one correct way. And this is a homework example, more like an activity for you guys that are doing this fresh right in 2021. Who knows where this video goes in the future. And so let's take a look at the problem and start working our way towards solving it and finally doing everything the correct way using pushes and pops, the call times, the runtime stack, and parameter passing, local variables, and so forth. So here is my function. I borrowed this from the advent of code. I think it was 2 years ago now, so the 2020 or 2019 edition of this. And it's a very simple problem. I mean, we can't really get too much more than this in our 16. And so basically, I'm just running a number through and reducing it down. And the whole point of this from the problem, from the advent of code, was you're trying to shoot a spaceship into space. You're like, well, how heavy is my spaceship with the fuel on it? But then you need fuel to carry the fuel, and you need fuel to carry the fuel that carries the fuel, so you can get yourself up into space. And so the goal was to figure out how much actual fuel you needed to get this into space, given the fact that you're burning off fuel and this and that. You know, integral calculus and whatever. I mean, it's all what it is. But anyway, so this is our problem. I'm going to set up the main first, since that's the easier one of all of this. And so system pause is just a call wait message. And then here, so this is the new way to do things here. So a function parameter would be something that I push onto the stack. So there's my 100756. Excuse me. So that's how I push a parameter onto the stack. I call my function, and then now let me just set up the basics of this here. I'll call it function here and function proc. And just for the moment, I'll have it ret. This isn't fancy just yet. We'll do that in a minute or so. And so there's that. So I'll call that function. And then theoretically, whatever comes back out of here will be in the EAX register. So I can just call, just right away, write int. And so, because again, in C++ or any higher level language, I'm trying to tell you to use a register, but I can't just outright do it. Like Python, I could get away with it since it's not strongly typed like these other languages are. But as you can see here, so the EAX register will hold the result. I just go and print it. I system pause, I return. That's my goal here. This is, this push, this call, and so now we're ready to move on to this. So the parameter is going to be stored in the call, the runtime stack. And this local variable is going to be stored in the runtime stack. Instead of notice there's no globals here at all. There's nothing in this program that screams out I need a global. And so we need to get this done using, setting up the EBP and ESP register. Let me show you how. So over here in function now, anytime I set up a parameter or anytime that I set up a local variable, I have to tinker with the EBP and ESP register. So, and this part is always the same. I push EBP onto the stack, and then I move ESP into. And that's just to give ourselves, what they say, I call it a foundation, basically an unchanging point from which we can access our local variables and our parameters. But right now we don't have, this is just to set up the parameter that gets passed in. This is not helping in any way right this moment with the local variable. So for every push back here, I got to do a pop, put the EBP back. And you're like, why do I have to do this? I mean, it's kind of unimportant, but the whole thing comes down to if you have functions calling other functions and those functions call other functions, things get very complicated very quickly. And as you guys may have noticed from previous problems and previous things that you've done, is that registers, there's only the 8 registers, and 2 of them are pretty much maintained automatically. So you only have 6 registers, but you need EAX and EDX to do multiplication and division. You need ECX to do looping, and you need this and that for other things. It gets and ESI and EDI for other, it gets very complicated very quickly. And so you want to make sure but the registers stay in the way that they're supposed to stay. Okay, so this handles the the EBP and ESP registers just to get ourselves set up. And now what we do is if we every time we pass a parameter in, we have to ret with a value that's 4 times the number of parameters that get passed in. And that's because when I hit this ret and I return back, whose responsibility is it to pop this value off the stack? And so, and you could say it's the responsibility of main. If they push it, they should pop it. And I won't disagree with you there. But the conventional way of doing things, and conventional means, compilers and all the automatic tools that work with C++ and other, and in this format require you to ret on the function side. So you just want to make sure you follow along, because you never know what, maybe one day one or two of you out in the world will create some assembly language. I mean, honestly, it seems, with embedded machines and embedded architectures and things like that, that seems to be more and more of a thing. That you want to make sure you follow the correct way, the way that everyone agrees on doing things, instead of doing things your own way and then wondering why, the world doesn't agree with you. So anyway, so if there were 2 parameters, I would return with an 8. And before today, or before this week, we never pushed anything onto the stack. That's why we never put a number here. But just remember, it's always 4 times the number of things you push on the stack for parameters. Okay, so that covers getting us going here. And so what I can do now here is set up the local variable. And so what I do here is I do a subtraction from ESP, 4. And again, this is the same kind of thing. There's one local variable here. So there's 4 times that number here when it comes to how much I subtract off. And on the other end, I add it back in. And so that will take care of everything. Let me pop this thing into Visual Studio real fast. And I want to change things around just slightly to show you how you can take something like this and hopefully make it a little easier for you to translate into some. And here you see, just so you know what you're trying to work toward, if you run this program in C++, I did it in Visual Studio, you get 50,346 for your final answer. And so, excuse me again. So the reason why I brought this over here is so that I can translate this a little bit. Instead of using x's and totals and getting yourself all confused, you could start working a little bit differently. And what I like to do here is, I can take x, and every time I see an x in here, I could do a global replace. I don't want to complicate things. I'm going to change x, and I'm going to call it +8. And the reason for that is that's where in memory, that's EBP +8. That's where the first local, or the first parameter that gets passed into my function, that is where that thing is stored. Wherever EBP is, 8 bytes past that is where this variable is going to be stored, where my 100,756 is going to be stored. And the reason for that is, just think of what's happening here is you're pushing this number on the stack, and then you call the function, but when you call a function, you're pushing an address, the return address, basically line 21 here. Like when this function completes, go back to line 21. So there are 2 things on the stack, and then you call this, and then you push EBP on the stack. So there's 3 things on the stack, and then you got to go back 2 places to get yourself to here. I don't want to complicate things too much, but just to say the first parameter that gets passed in is going to be at EBP +8. So I can go ahead, and every place I see x, I can just replace that with that. And total is going to be -4, because that's what I did here. I set everything up here with the sub ESP, 4, add ESP, 4. And so every place I see, I didn't replace that. I'll do that in a second. Every place I see an x, I replace it with +8. Every place I see this, I replace that. And let me just make sure I did everything correctly by running my program and making sure I got myself to the same result. And I did. Oops. Okay, so now I can begin the process of going ahead and translating this guy. And so what I can do here is I'll do this line here. And that's pretty simple, right? I can just say move into, and let me just do it what you would think you would do it. You just say EBP -4, and then I would say comma 0. And you think, well, what's wrong with that? And when I try to build this, show you, failure came up, and it does say invalid instruction operand. And that's because when you do this, this is just a memory address. I mean, it could be, it's just some place in memory. This is not a high-level language, so it does not understand. Am I looking at a word? Am I looking at a byte? It's not a global. There's nothing here to indicate what I'm actually staring at other than a memory address. So the fact that I put 0, and 0 doesn't help me. 0 could be in any number. I mean, it could be 1 bit. It could be 5 bits. It could be 100 bits. It could be 32, 64, you name it. So I have to go ahead and say, hey, take this memory, treat it like a double word, treat it like an int, a 32-bit quantity, and put a 0 in there. And then now this will work. That's where the D word pointer comes from in this case. Okay. So then that's that here, and then that's this line of code. So now let's look at this while loop, right? A while loop is just a repeated if statement. And so I can say this again, and I can call this done, and I can do a jump to again. Let me bring this out here. So this is our while loop right here. And so what I can do is I can compare, let's say D word pointer, EBP plus 8 to 6, and remember again, an if statement, in high-level languages you go, what do I do to stay in the loop? Well, when you're writing code, you think the exact opposite. What do I have to do to get out of the loop? And in this case, I want to jump if, the opposite of greater than or equal to is less than, and I'll do jump if less than done. And so that covers that, and then we'll do code here. We'll do this in here, because that's what the body of the loop is, and then we'll jump again, come back around, and then we'll do a comparison, and then we'll eventually get out of the loop, fall out here, and we'll fill in this in a minute, but the last step here is, because EAX is supposed to hold the return value, I can go take whatever is at EBP minus 4, move it into the EAX register, do all the extra stuff to put everything back how it was, and then call it a day, and everybody's going to be happy. So this will run. It still won't give me anything of value. Yeah, and it does give me an infinite loop because it is in here. There's nothing changing anything in here. So if I put a breakpoint in, you can tell it's hitting that. It's inside of here indefinitely. So our last part here is, let's get rid of that infinite loop by filling in these 2 lines of code and get it to work. Okay. Let's start looking at this line of code. Plus 8 equals plus 8 divided by 3 minus 2. And so the first thing I want to do is just take plus 8 divided by 3 and say you don't have to think about changing things up, but I do have to start thinking about how to get this division going. And I'm going to use idiv for this. And so we can let me start putting stuff in here. We're going to work in here. So I'm going to move into the EAX register. I am going to move D word pointer plus 8. And I wish I could just do idiv 3. How about 3, Brad? But you can't do that. You can't just use an immediate value for an idiv. So I do have to move this into something. But also, remember, idiv requires me to use the EAX register and the EDX register. And this CDQ extends whatever value is in EAX into EDX so that the value works out. It's either going to put all 0s or all 1s in there. And so now I can do something else. I can say move into EBX. I can move a 3. And now I can idiv EBX. And so that will do all the work here. Move plus 8 into the EAX. Move it also into EDX so it's ready to go. Divide by 3. And now EAX holds the result. So I can also then go ahead and subtract, just to finish up the thing, the EAX register, subtract off 2, and then move that into EBP plus 8. A lot going on, right? That's all of that is for this 1 line of code. 6 lines of code in assembly gets me this guy here. So take EBP plus 8, bring it in, get it ready, divide it by 3, subtract off 2, and then move it back into where it was. Okay, so then this still, does this still do anything? Does it still infinite loop? Nope. At this point, it still returns a +0 because the EAX register, the EBP -4, our local variable, is never being modified because we haven't fixed that up yet. And so, yep, it's returning a 0. So far, so good. And so you would think, one last thing here, is that you could move directly dword pointer, and you could just say, okay, take whatever's at EBP -4, and just take whatever's at dword pointer EP +8, and you would just say, okay, we're done. Game over here. And you go, nope, invalid instruction operand. And again, remember that what is EBP but something on the call, the runtime stack. Where is the runtime stack? It's in memory. It's RAM. And so the rule of thumb is when you're dealing with moves in pretty much every operation, almost every operation and every form of it, you have to have at least one register involved. It's not I guess the rule is the rule really is you can't use more than one piece of memory at a time. The address bus and all the way the CPU works is that you can only access in one line of code, you can only access one piece of memory. And so we just need a middleman here, like a register, to just say, okay, how about I move into EAX this guy and then move it over there. And why am I using EAX? It's because I'm done. I'm done using EAX. I'm done, this line of code is complete. The registers have done their job, and so I can move on and use EAX for other things now. Take it, put it in here, move it, and now let's see, do we get our 50,300 and whatever? Nope, we don't. We get +2. So now I'm going to have to look to see, what did I do wrong here? Or what do I need to fix up to get this thing to work? I actually did think I was going to get this. See my mistake. Why do I get a +2? I have a breakpoint in here. The reason I get +2 is because what are these two lines of doing? What I'm doing is I'm doing a move and a move. So in essence, I'm actually, instead of doing plus equals, I'm doing regular equals. And so I want to do a plus equals. I still do the first move to get the thing +8 into memory, and I'm sorry, into RAM, into a register. Sorry about that. And so once I have it in the register, then I can add it to whatever I've got going on here. So let me add this instead. Now this is a plus equals operation, and now when I run this, I get my 50,306 that I was expecting. And so just to be on the safe side here, I can also add a CRLF just so you can, excuse me, see this. Oops, I put it in the wrong place. Just so it's all a little more clear. And you can see that the number's there, of course. But there we go. There's my 50,346. So this code, I mean, all of this code here gets the job done. How many lines of code is this? In 27 lines of code in assembly with a couple spaces in there. 24 lines of code to do a few lines of code in C++. And so you're like, oh, I'm done. Well, but there's the final step here, and we do this for every function, is we go through here and we say, well, what registers do I need to, were modified, and which registers do I have to put back? We already dealt with EBP. We already dealt with ESP. So only the other 6 we have to worry about. And I guess technically 5, because EAX does not have to be worried about because we're returning a value through there, so we don't want to put back, after doing all that hard work, we don't want to put EAX back to what it was. So it's EBX, ECX, EDX, ESI, and EDI. Those are the 5 registers that I have to go through and go, did I modify them in my code? And sometimes it's easy to tell, and sometimes it's not. But what you can see here is I am modifying, coming in EBP, dun dun. I'm again, anything EAX is fine, but notice here, I'm using EBX, so I do have to go. And where do you put that? Right, that's always the fun part. You put that after all the other operations. So I need to push EBP. I'm sorry, EBX, and then down here, gotta make sure I do everything in the right order. Okay, pop. EDX, EBX. Oh my goodness. It's Friday on my end here. So you're just thinking of the weekend. Anyway, so EBX does get used, and then you look through and you go, oh, nothing else is used. But remember, you have to like say directly or indirectly. I did modify EDX by using the CDQ operation, and I blew out what was in there by using the IDiv. So I do have to also make sure I push EDX onto the stack and pop it off. And again, I got to do everything in reverse order. That can get tricky, as you can see here with everything else going on. But let's see, I did not use ESI or EDI, and I did not use ECX in this function at all. And so only those two things on top of everything else need to get pushed and popped. So let's see, push EBP, so EBP, ESP, EBX, EDX, and then in reverse order, EDX, EBX, ESP. So that does complete the program that, everything is now in a happy state. I did not use any variables at all, global variables whatsoever. I used the call time stack for everything. Everything got pushed and popped off, and basically we're using the free memory we have to begin with. We're not adding anything more to the program because the call time stack is always there because it's a necessity in any kind of modern programming. And so we get the job done. We push a parameter on the stack, we call the function, this does the hard work, puts all the registers back except for EAX, and then I can write that value out, carriage return line feed, and get out of here and call it a day. Okay, so I hope this video was useful for you. If not, or if you have questions or concerns, and if I misspoke about anything you see here, just please send me a message at swardb@cud.edu or comment below, and I'll set the record straight. Nothing I ever try to say is intentionally wrong. I don't, this stuff's hard enough as it is, especially as we're moving into the final weeks of the program here, and it's a lot of code going on to do something that's pretty simple. And I want to make sure you understand going into the final so you can nail that final, get your A, and get on out of here. And go on to bigger and better things. Thanks for sticking it out with me as always. Thanks, everybody. Have a great day. We'll see you next time.